Hello and welcome to this video about the quick start guide from Axelera. My name is Jonas, and in this video you are going to learn how to quickly get started with the Voyager SDK. So just for reference, in this video I'm talking about the version 1.2.5 of our Voyager SDK. You can see here the GitHub page with the README document. And the document that I'm referring to is the quick start guide. If you click on that, it will open this README file here, which walks you through the whole setup of the quick start guide, as in what our development environment is, what the runtime environment is, what they do, what we do with the Voyager model zoo, how to train your custom weights and your custom dataset model based on one of the models from the model zoo. It explains what the Inference.py does, how to set up an application on top of that, the Inference server, and so on. But what we want to look at right now is basically to run an inference on a model and then on a camera stream. So this is really all what this command here does. It runs inference on a model on a camera stream. So how do we actually do that? First things first, you start by entering the terminal on either your eval-kit system or your Ubuntu system with the Voyager SDK installed on it. The first thing that you have to do is you activate the virtual environment. So you go to source, then you say virtual environment, venv, bin, activate. So in my case, this is already activated. You can see here it says venv in front of the Ubuntu prompt. So the virtual environment is activated. Now, as a next step, we have to make sure that the camera which is connected to the system is also recognized by the system. I'm just scrolling up here. So with this command, v4l2, you can basically list all the cameras that are being connected to your device. If you don't have it installed on your Ubuntu image, you can basically just get it with the apt-get install. Now doing this, you see that here in my case, there's this HD Pro webcam C920, which is connected to the system on the USB 0. And that's all that we need to know, because now we can basically just go ahead and run the inference. Now, what model do we choose for this? In order to know all of the models that are available in my Voyager SDK installation, I just go ahead and say make. Running that will create this list of all of the different application pipelines, then the tutorials down here, and a list of all of the models that we have on our installation. Now, going back to the quick start guide, we want to run the YOLO V5S V7 Coco. So this is a YOLO V5 model S, so the small one, V7 subversion 7, and then trained on the Coco dataset. So in order to do that, we have to look here if we have this specific model on this Voyager SDK installation, and here it is, YOLO V5S V7 Coco. So now what we could do is we could run this inference command as is in the quick start guide, and what this would do is it would basically pull the model and then compile it locally on my system. However, there's a quick trick how to get even quicker to this result, and that's by using the download prebuild function. So I say // and then download prebuild. I autocomplete with tab. And now I basically just go ahead and choose the model that we've been picking previously. So in this case, the YOLO V5S V7 Coco, so this one. Then I just do copy paste because I'm lazy. And now what it does, it will download a precompiled version of that specific model and already put all the relevant files into the relevant folders, such that I can basically just execute it. And now I just go ahead and copy the command from here, from our documentation, and paste it in here. I press enter, and now what it does is it basically deploys the model on Mattis, on our chip, and opens this inference here. Okay, so what do we see? Basically, this is a recording from the camera. The camera is actually recording the physical screen. So if I draw the window over here, you see the window in the recording in an endless loop. What it shows is it shows these 4 wheels down here, saying the temperature of the chip, the CPU utilization, which in this case is only 2%. So there's a lot of space still left on your CPU. The frames per second, which is 30 frames per second end to end. Why is it only 30? That's because the camera only records at 30 frames per second. Now, in order to test this model, what I can basically do is I can go ahead and open this window here, which is a blog post from our Axelera blog. You should definitely go and check it out. And now what you can see here in the inference is that the camera is detecting persons on the images here and labeling them. So basically it works. And that's basically how easy it is to run inference on a camera stream with Axelera's Voyager SDK. Now, you might not have a camera, so there's an even simpler way of trying it out, and this is by actually running it on media. For that, you need to make sure that in the installer, you also download the media into your installation. You can verify that by basically looking into the folder, because there will be a media folder in the root directory of your Voyager SDK installation, which will have some files in it. Now, in our case, what we are going to do is we are just copying again this command, and I will quickly explain you what it does. So again, it's inference.py. It's the same model that we had before. And now you tell it to not draw information, not draw a video from a USB. But this time we say, take it from the media folder and take this specific video. So this is a video of a traffic situation from the media folder. Pressing enter again will do the same thing that we saw before. So we deploy the model on a chip and then we start to run inference and display here. Now you see it's much faster. It's 777 frames per second. So that's because now we are not limited anymore to the stream of the camera, but we can go basically full power. And we see here in the outputs, the end-to-end performance of this specific network is on average across the whole video 783.3 frames per second. So that's how powerful Metis is actually when running across this video data. Now you can go even one step ahead and do even better benchmarking on a data set, for example. And that's something which is shown here in the last one, in the measure model accuracy. So now we don't choose a video stream, we don't choose a video file, but we run across a data set with a whole lot of images in it. In this case, it's a part of the COCO 2017 data set, so 5,000 images from that. I will paste again the command as before. This time we are adding this additional flag here which says no display. So before you always saw this little display window which shows you the inference. In this case we don't need this because we will anyways just crush through a lot of images. And now pressing enter, you will see the same thing happen again. Model gets deployed on the chip and then we actually start to run the inference. So now it runs through these 5,000 images here at roughly 450 frames per second. And then at the end, what we get is we not only get the average frames per second that we saw before, so these 450 now, but we also get some accuracy metrics, like for example the mapbox metric here. And there is other ones as well. And that's already it. That's how easy it is to run on a video stream, but also on a video file or on a dataset inference using Voyager SDK and the Metis chip. Thank you very much for joining for this video, and I'm looking forward to see you in the next one. Bye bye.